Hi there, I'm Jacob, and this is MakeCode Arcade. In this video, I'm going to be talking about finding the distance between two sprites. But before we do that, I'm actually going to draw a triangle, which may not seem to be super relevant, but hopefully I can demonstrate the relevance in this video. So we're going to start out by drawing a horizontal line, and I'm just drawing directly to the background image here. And then we're going to draw a vertical line. So we want to start where we just ended from. This is going to start at 70, 70, and then we're going to go up, which means closer to 0. And then our final line to complete the triangle is going to go from 30, 70 to 70, 40. So it's going to close up our start and our end points. And there we have a right triangle. Now if we wanted to know the side lengths for this triangle, it's pretty easy to do for two of the sides. So the horizontal line here goes from 30 to 70 in the x dimension. So the difference of those is 40. So this line here is 40 pixels. And the vertical line only changes in the y dimension, and that goes from 70 to 40. So this is 30 pixels long. But this diagonal hypotenuse line, you can't really, by just looking at these coordinates, know how long this line is. But if you've taken any geometry, you've probably encountered the Pythagorean theorem, and if you haven't yet, you probably will at some point. And it states that a squared plus b squared is equal to c squared. So we can build a function in MakeCode that will actually do that. Let's call this calculate hypotenuse length. And it's going to take two parameters, a and b, which will represent the lengths of the sides that we were just talking about. And so this function is just going to return a value. If you don't have this return block, you may need to use the beta editor. It hasn't made its way to the full editor yet. So if you go to look for a return block and it's not there, you may just need to use beta. I think eventually it's going to make its way over to the main editor. But we're going to return the square root of the sum of, now we want a squared and b squared. We could use multiplication to square this by multiplying it times itself. Or if you hit this drop down, there's the exponentiation operator. So we can raise a number to a power. So we're going to set 2 there to square a and b. And if we look at this now, we have a squared plus b squared. It's going to give us c squared, which we're going to take the square root to get the length of c. And then to display it in our game, we can use the set score block. It'll just put a number up in the upper corner. And we can call calculate hypotenuse length, giving it our 40 and 30. And we find out that this side of our triangle is 50, which seems reasonable. This is 40, and this is going to be slightly longer. So yeah, 50 seems like a reasonable number. This Pythagorean theorem is pretty interesting. There are lots of proofs of it, and we're not going to get into that in this video. But there is one visual explanation of it that I found pretty compelling, and so I built a different non-game MakeCode Arcade game that shows this visual proof, and we'll just walk through it quickly. So here we have two large colored squares, and they have the same dimensions, so they have the same area. And within these squares, we have 4 identical triangles arranged in different configurations. So in this purple square, we can look at this short side of these triangles and see that they form a new square here. So if we call this side A, then this would be A squared. And if we come over here to this medium length side and call it B, then this area here would be B squared. And then moving over to this blue triangle, we've arranged the triangles around the outside, and the hypotenuses form this interior square. And so if this side is C, then this interior square would be C squared. And because these colored squares have the same area, and these triangles occupy the same amount of area in all of them. If we subtract out that area, then what we're left with is equal. It has to be the same. And so we can see that a squared plus b squared takes up the same amount of area as c squared. So I just thought that was kind of a neat visual explanation of the Pythagorean theorem. But we said at the beginning of the video that we're going to talk about the distance between two sprites, and our game doesn't even have any sprites. So let's fix that. Let's put in a couple sprites here. MakeCode, as you may know, has a gallery. You can pick pre-built assets, and we're going to grab this princess here. Let's rename this to Princess. And princesses like to eat, so let's grab a pizza. And we're going to name this variable pizza. And let's go ahead and add the ability to move the pizza around. Maybe the pizza doesn't want to be eaten by the princess. So now we can control our pizza with the D-pad or the arrow keys on the keyboard. And we can move it closer to and further away from the princess. And it would be nice to know how far away they are. So we could probably compute that with some math, but before we do, I'm going to draw some more lines on our canvas. And I'm not going to put this draw line command into onStart, because this onStart only runs once, and we want to do this as the pizza moves around. So we're going to grab an onGameUpdate. And if I start drawing in onGameUpdate without clearing the background, then those lines are going to get left over. So first I'm going to fill the background with nothing. There we go. And now I can start drawing lines, and they won't get repeated. Let's grab this. And we need some property accessors for our sprite. So we want to draw a line from our princess's x and our princess's y to our pizza's x. But I'm going to stick with the princess's y for now. We're just going to draw a horizontal line. So now when I move the pizza around, if I move it around side to side, we have a line that connects them. But if I move the pizza up and down, you'll see that the line does not connect. So that's cool. Now we can draw a second line here. We'll do it from where we left off. So we'll go from the pizza's x to the princess's y, and this time we're going to go from the pizza x to the pizza y. And let's see what that gets us. So now we have a line that will go up and down to meet the pizza from where the line that we last drew left off. And we're going to draw one more line, and you may see where this is going already. This one is going to go from the princess to the pizza. And now we've made a right triangle, which we've already talked about. And this line here, this diagonal line between the princess and the pizza, sure seems like the hypotenuse of that right triangle, which we know how to calculate with the Pythagorean theorem. You may also have heard of this referred to as the Euclidean distance formula, and in this case, with 2 dimensions, it totally is the same as the Pythagorean theorem. So we can build a function now, I think. Let's call this calculate sprite distance. And it's going to take 2 sprites, a start and an end. And for this one, I'm actually going to make a new intermediate variable. We're going to calculate the x distance first. That's pretty easy to do. We just need to subtract the x position. Oops, let's put that in there. The x position of the start sprite from the x position of the end sprite. And you may get concerned as you think about this that, well, in some cases that's going to be negative. And in fact it will, which seems odd sounding for a variable named x distance, but If you think about what we're about to do, we're about to square this number. And when you have a negative times a negative, you end up with a positive. So in our case, it's not going to matter whether we come up with a negative or a positive value. And now we're going to do the same thing for the y's. And so these numbers here, what we just computed, this x distance represents this length right here, and the y distance represents this length right here. And now that we have those values, it's merely a matter of using them in the formula that we already wrote. Let's get a getter. And so now our x is like our a squared, and our y is like our b squared. So we have x distance squared plus y distance squared, and we're taking the square root of that. And that's going to be the distance along this hypotenuse here. Let's add a set score to print out the result. So we want to call calculate sprite distance with the princess and the pizza. Get rid of that. And so now as the pizza moves around, you can see our score is updating to show the distance between the princess and the pizza. I was thinking about maybe some games that could take advantage of this. One example I thought of was you could have an enemy that woke up as you got closer to it and maybe fell asleep if you got further away from it. Or in a recent MakeCode Arcade Advanced stream by the MakeCode development team, they were building a tower defense game. So you could use this distance formula to determine if an enemy was within a tower's range before it started shooting. There's lots of applications of this calculate sprite distance method here, this distance formula. And I would love to see any games that you make using this equation. If you make one, feel free to post it to the forums. Lots of people are there checking out games and commenting on them and giving little hearts, and it's lots of fun to see what people make. But I hope this video was useful to you. I hope this formula here is useful to you, but also that there was something interesting. Maybe you learned something. So have fun making games, and thanks for watching.